Okay, guys, we're about to do some interesting experimentation. All right, so I'm going to show you something. Check this out. Now observe the distance from which this suddenly wants to flip over. It's right about here. And it's right about the point where I start to feel electromagnetic force. No, I feel it really about here. I can feel it. But when you go back further, if you're really sensitive in finger, you can feel it from way back here. And look at that. That's how far away that is attracted to. But why did it stick way down here? Because it had to escape the electromagnetic field of this. What's fascinating about that is these are pretty powerful rare earth magnets. And this end was a lot closer than this end. And yet this end drew it all the way around that field to down here where it wants to stick. Up here, I can force it, but you can feel the pull of it. And left alone in gravity, it had to go a fair distance below it before it was attracted. Why didn't it do this and flip over in the air? You can see that it has a tendency to want to do that. Why didn't it just flip immediately over and be drawn into it when they're that strong that I can barely pull them apart? So here's another question for you. That's one. Now let's take this coil. You noticed when I started the video, it was there. Now I've already demonstrated that this should happen. But let's just see here. We still get the same effect. And it happens, believe it or not, about the same distance away from what I'm seeing. And this, of course, will be attracted to the magnet, right? These are strong electromagnets. So strong that even just putting the coil in between, even if it wasn't attracted to the coil at all, it would still do this effect. But this is a suspension of electromagnetic fields. This field wants to join this field, but they can't because something is preventing it. Well, it's pretty obvious in that case what's preventing it, right? Now here, what about this? I can feel the repulsion. And yet, I can put them together. Not only can I put them together, I can make them stand straight up like a tower. How are we suspending this field? It doesn't seem to want to do what you would expect. Why now didn't it do that right away? I'm going to show you one more time, and we're going to do it a little bit different, and I'm going to show you how strong its desire to stay in place really is. Look at this. I've got serious repulsion here. No matter how I turn this, if I'm trying to put this end to this, it doesn't want to be there. But watch this. Now, for some reason, when I put it here, not only does it want to be there, but I have to agitate it a fair bit before it moves. So watch this. This is really neat. Watch this. So we go like this again. We overcome the repulsion. We set it in place. And now I put it to here and I let it go. And what do you see? Now it jumps to it. You want to explain that? Let me show you again. Watch this. Now I can take that, hold it down fairly far, and it comes right back up. That is a suspension of electromagnetic fields. This is being held in this position by very specific electromagnetism laws. Somebody explain that to me, will you? Because as far as I know, the theory says that shouldn't be possible. And yet, it clearly is. This, look at that, it just jumped off of there in my hand, man. I'm so glad I had this filmed. That was so cool. This exhibits such cool qualities. And after doing these kind of experiments for a while, in one of my other videos, I saw the magnet stack jump to my hand. No, away from my hand. In this case, it just jumped into my hand. Literally, it was forced off of here and flipped into my hand. But why? And why was I able to put it right back if there's so much force saying it should flip off? But there is. The force here should be flipping this upside down. And yet it's not. I can make it, but I can also demonstrate that It has a real strong desire to stay in this position. It is not loosely here, but held securely in suspension.